The first thing we did is that we took the numerator and we multiplied it by -1. We did this to make it positive. Then we factorized it. Then we took the denominator and we factorized it as well. However, we wanted to make it smaller, so we used common factor. At the end, our simplified function became minus multiplied by 8x minus 7 multiplied by x plus 5 over 2 multiplied by x plus 2 to the square.
In order to find the horizontal asymptote, we must take the values that multiply x squared. X squared is the highest exponent x in the original function, so that's why we're taking the values that multiply these, which are minus 8 and 2, leaving us with y equals to minus 8 over 2, and this equals to minus 4. Minus 4, y equals to minus 4 is where the horizontal asymptote is. For the vertical asymptote, what we need to do is take the denominator and equal it to 0. After we do that, we basically isolate x, and that leaves us with x equals to minus 2. Now, that means that the vertical asymptote is in minus 2.
Now we'll find our x and y intercepts. For finding our x-intercept, we will need to take the numerator of our function, and then taking each part that has x equal to 0 for us to isolate the x. In the first part of the function, we will have 7 over 8, and its coordinate will be 7 over 8, 0. And in the second part, we will have x equals to -5, and the coordinate will be -5, 0. Now, for finding our y-intercept, the only thing we need to do is to evaluate our function with 0. This process will give us our y-intercept, which be 35 over 8, and its coordinate will be 0, 35 over 8.
Domain and the range. For the domain, we are going to take the value of the vertical asymptote and put it in intervals. First, it would be minus infinite, minus 2, union minus 2, infinite. For the range, we are going to take now the value of the horizontal asymptote, which is minus 4. So the range would be minus infinite, minus 0, union minus 4, infinite. We're going to graph the asymptote. We're going to start with the vertical one, which has a value of minus 2. You locate minus 2 in the graph and you put a dotted line which crosses that point. After that, we are going to graph now the horizontal asymptote, which has a value of minus 4. You locate minus 4 in the graph and you put a dotted line to identify it. After that, we are going to locate the two x-intercepts, which is 7 over 8 and minus 5. First, we're going to graph minus 5. You locate it in the graph and you put minus 5 with the coordinates, which are minus 5, 0. After that, we're going to locate 7 over 8. When you locate it, you put a dot and you put the coordinate 7 over 8, 0. After that, we're going to locate now the y-intercept, which has a value of 35 over 8. You locate 35 over 8 in the graph, which has a value close to 4, and after that you put a dot there and you put the coordinates, which are 0, 35 over 8. After that, the last step is to, draw the line of the graph. You are going to start by drawing the line as close you can to the horizontal asymptote, and then you are going to start drawing it upwards, crossing the minus 5 and then going up, close now to the vertical asymptote. After that, you are going to go to the top right quadrant and you are going to do the next graph there. You are going to start up first, going down close to the vertical asymptote, then touching the y-intercept, which is 35,8. That is the point you previously draw. You cross it, then you go down, 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 and cross now the other x-intercept, which is 7/8. After you cross it, now you go down, start getting close to the horizontal asymptote, and keep going until there's no more space, and that's it. Now you have a perfect graph of the function.
Sashay away.